How are you doing tonight? Great. One person is doing great. Anyone more? Cool. Um, anyone succeed of completing our homework? I mean, like not a homework, right? But this nobody. Game of life. You did. Two of you. Anything else? 3, 4. Cool. Right. You're going to have a first homework tonight. I'm almost finished like requirements, so I will push it after our lesson today. I think this will be 1 week homework, just a really easy one, and so on. So I hope you will enjoy your weekend. Anyhow, like today we're going to talk about really controversial, complicated, topic. It's actually about metaprogramming. And initially, metaprogramming was something that Ruby was famous for. These days, it used not that often because several reasons. I will talk about them later. But to demonstrate power of metaprogramming, I will just start with really easy exercise with you and so on. Anyone actually can you give me a definition of what the metaprogramming is? And you have any ideas?
It's when you write code that after that write another code.
So okay, it's one of the most famous ones, like metaprogramming and the writing code, so which writes another code. So it's kind of like it's the very end. Like if you go this direction, like programmers will replace developers and you lose your job, which will not happen in real life. But actually, it's true. So like during my school time, I actually have a really interesting thing to do. So basically, like one of my one of my classes, like we actually were like all like 3 months or 4 months class, we just were multiplying matrices, like in different ways, in different like shapes, using different like libraries, different stuff. But like all 3 months we were multiplying matrices. And we did this in purpose because we actually was trying to measure performance, how fast we multiply in matrices, and multiplying matrices is one of most like CPU consuming and so on. And to measure performance, actually, we need to calculate number of moves and sums. So like every time you take in a sum of 2 digits, you kind of like calculating this, and every time you multiply digits, you just calculate again. So like, and if you're coming from C world, like how you can just calculate number of multiplies and sums on your application. What you're actually doing, you creating a stupid variables like saying adds or moves, and every time you like doing this, you actually like kind of increasing this variable all the time. And I cannot say it's a really smart decision, right? Like because like you can mess up with it, like missing somewhere, like if you're doing something wrong. So, but this one actually works. If you going to compare, let's see, we have a matrix 40 by 40. I need to compile this. Cool. And now if I run in my application this way, it shows me that I have 64,000 adds and moves. And if I change it to 60 by, 100, for example, I need to compile again, actually. Make. And now it's segmentation fault. Cool. Because you cannot multiply this type of matrix. Make again. So like 1 million, I guess, right? And if you write this program in Ruby, it will be much simpler. Like it will be just Z1, only 23 lines. And actually, you're doing here like the same stuff. You define 100 by 100. You define the matrices. It's a 2 source matrix. It's a result matrix where you kind of place in your results, and that's it. So you kind of compiling. It's Ruby, you don't need compile. I'm joking. So like million, if you increase it to 1000 about 1000, it will take a time actually, I guess. I'm not sure how much time it will take, but I assume it's a what? Okay. Should it decrease number? Come on. I told them you're not as slow. Okay, it's still 2. Let's take 300 by 300. I hope it will work fine and fast. Yeah, here we go. 27 millions. Cool. So and at that time, when I was like kind of practicing and executing this task, I was dreaming like, can I actually, you know, like instead of doing this stupid like adds and moves and increasing here and there, can I actually make some trick then when every time when I doing my like plus or doing my like any operation, can I just have a variable which will be automatically create this like for me? So what do you think? Can we do it in Ruby? Do you get an idea? Like, okay, I'll repeat the idea again. Like, so let's imagine you have a class, right? And Ruby, every digit, if you, I think you know this, like, if digit is actually a class, right? It's an integer class. So every time, and actually, like when you run this one, it actually calls star method, or if you're doing this one, it calls plus method on this object. So basically, it's similar to saying like, hey, can you actually call me plus and end me like second one? So this is one as a method defined on a class. And in theory, we kind of can hack it some way that it will be calculating how much it was called, and at the same time, it will be executing itself. Do you get an idea? Anyone?
Maybe write class variable for some.
Let's start with. Did you get an idea? It's important. I see like smoke in your eyes. Okay. Let me try. Okay, let's start with let's leave it out. Let's start with something more basic one, right? So actually, like why everybody loves Ruby and hates Ruby at the same time? So you imagine you have a Java or C++ or whatever, right? And on Java you have like integer class, which actually I'm not sure if it's in Java or whatever, integer class, and on this class like it's where all the math operations happening and so on, right? Can you do anything like with this class in Java? Can you kind of, you know, destroy it, replace it with your own class? Anything? It's a question for you. Or Java or C++, or I'm not sure. I think even on Python you can do it very easily. Can? There's yes or no. Who thinks that you can do anything with this class in Java? Yes? No? 3, 4, 5, 6 people no. Other people? Yes? Come on, you're not winning like a lottery, like you just, you know, saying your opinion. Yes or no? Once again, yes? No? 1, 2. Like more people know than yes. Well, and it's actually true. Like on usually like classical programming languages, you cannot do anything with the basic classes, which is not true in Ruby. In Ruby, what you can do, you can actually open up this class, type anything you want, say like 1, 2, 3, and the variant you will have number which you can call ABC, and you can have puts, and here we go 1, 2, 3, which is kind of like kind of crazy, right? You just, you know, open up any class and so on. And I think ABC, no, it's ABS anymore. And same time you can do really crazy stuff. For example, as you probably know, any method in Ruby has 2s, which is to string, right? And it will give string representation of a number. And what you can do, you can open up a class and say, hey, it's actually will be 1, 2, 3, and here we go. It's 1, 2, 3. And if you I think if you even like puts in 2, it gives you 1 to 3, which is kind of crazy, right? And even more if you like go and put any digit you want, too much numbers, it still gives you 1 to 3. So every object in the system right now has ring representation of 1 to 3 in Ruby, and it's a power you get and responsibility you get, because this way is it really easy to break any flow, any change on Ruby. And one of probably, no, we're not going this direction. So did you understand? Like it's called, actually this one is called monkey patching. Like a monkey, it's patching any class and patching, right? So when you open up any class, you actually kind of you have ability to replace any method, anything in Ruby executing flow. So knowing this information, do you still think that like we able to go to integer here and do what we want? So like right now we have ability to open up a class and kind of like define any method you want, right? So what we want to do here, we want to open up a class which is integer, and every time we're doing like sum or like multiplying, we kind of like calculating how much time it was called, right? Let's try it out. So I would type code here. We have in class called integer, and actually I'm not sure if it's true. Let's just do a really stupid test. If I go this way and puts 1 to 3 and returns 42, what will happen? It will give me, okay, it says it needs to be, it needs to have second argument. Okay, second argument. Here we go, 1 to 3 infinitely. So you see, like somehow we break the logic, right? And actually I can multiply and prevent 42, and it actually should be calculating right. Let me decrease number of metrics size. So it's 42. Cool. Always 42. What if I would increase it to 10? It's still 42. Cool. Yeah, it's always it happens because every time we add in a number, it actually returns 42, which get inside into this variable, and they one kind of lives here, right? So it feels like we're right direction. So what we're going to do next? Actually, we need a variable. It will be a global variable. Please don't use them in real life. It's just for the demo purpose. We'll call it zoom and move and define it 0. And we're going to have sum was equal 1. And what should go here in ideas? Basically should be self plus argument, right? Is it true? Who thinks that it will work? Come on, well, be brave, like 3, 4, 5 hands. Who thinks it's not? Can you tell me a reason why it will not work? Just intuition. Say it again? Yeah, it's true. It will go to stack level to deep. And what happened? Because like you define the plus and use it again, and you go back and use it again, and go back and use it again. I can like infinitely continue. So it just goes here and here. So any ideas how like we kind of replaced our plus, right? But we need old one to do calculations. So how we're doing this? One of my lectures, it was really stupid ones, because someone told me that you actually can minus and use -1 multiplied by argument, I guess, and it probably will work. So you can use a brain and it still works, and sum will be sum -1 multiplied by sum, right? And Does it work? No. Oh yeah, we need to zoom and mouse. So it's 0. Why 0? Is it correct or not? Why it's not? Do it again. Oh, I mean like, yeah, I get it. You mean like 1. Okay, you can probably have it like this way, right? I guess so. Yeah, 3000. Here we go. So like, it feels like too much. Let's compare our results with the original matrix. It feels too much for me, right? What was the matrix size here? Let's make it 40 by 40. 40 by 40. Make matrix. So on original we have 64,000, and here we have much more, right? Matrix or B. I have no idea. Actually, like we adding them there, so we need to remove it, right? Here we go. It works. Problem comes up that we actually need to want to use like this one and still modify, and you probably can some way should be using mouse -1, and what I'm going to do here. Yeah, but problem is that like actually we're using this method here, so it will calculate it here, which is not really great one, right? And it will mess up with the data. You can use division, I guess. I see what you're saying, but like it's a tricky way, and it's fun because what Ruby allows you to do, it actually allows you to do ls method, which is like a really powerful mechanism where you can it's really actually powerful and stupid at the same point. You can actually alias your method to be something else, so we can actually like let's do some exercise. Like if I go and say ls method abc to be bdc, and I put bdc here. So actually, yeah, I need to place it here after a method. Here we go. For integer, sorry, it should be bdc abc. Different syntax. So this way, it actually will create copy of this method on Ruby, and see it will be used as an alias. So it's actually creating a copy. It's not like creating a symlink or link. It's just, you know, like you can replace origin. So with this knowledge, we actually can do a really stupid thing. We can actually have sum and copy and add 1 here, and then we can have self to call plus and add argument here, and also we have star method, for example, star. This one sounds like this could like a kiss and smile, right? Cool. Mu will be equal mu plus 1. What's the argument here? And self star argument. Here we go. I think it works. Cool. So I see people having scales. So actually, it's really cool. Like without touching or doing anything on our metrics or so on, we actually were able to calculate how many like sums and move operations we have source code, like without just touching and doing some variables and so on. How do you feel about this? You feel okay? All right. So this was like a really short demo of what I can do with metaprogramming when you know what you're doing and know how to do it. Because in other languages, like it will be not really like, and imagine you have like really huge system when you need to measure something like really this way, and like you don't want to go on every next line, so adding some plus or minus or whatever. So it was a demo. Let's go back to playground, and I'll tell you more about how actually Ruby works and what's inside it. So I think we already talked about how Ruby works in terms of like like really deep, like how code is being transpiled to different. Or didn't we not? Okay, let's do some like really stupid one. So you have to understand how Ruby works in terms of like how data is processed. Let's say you have really this way. You have a code, right? And code is basically just a string. So like you have 5 equal 1 plus 4. For Ruby as input, like all code you having is just like a string. So like just data is a string, and to be able to process it, Ruby needs to kind of map it against internal rules. For example, like if you write 1 equal 4, like plus 4, and execute it, it will be fine. But if you write 5% equal, it will be saying undefined method. And if you do any more crazy stuff like this way, right, it would say syntax error, because like it's not matching any syntax. And Ruby has a rules defined, like how define like what's the rules and how syntax is defined. If you're interested, you can go on github.com. I think it's Ruby. Once again, github.com Ruby. I don't have any connection. Cool. I hope our stream does any connection. Can anyone check a stream? Thank you. So like on Ruby, if you go to GitHub, you'll find this file. Usually it's called y-debug or something. y. Interesting. It should be a really big file, like syntax, reg syntax. Okay, I think they replaced these rules, but I'm just trying to find this struct. Probably it's somewhere deep inside. Weep. Oh, I know how to do it. It should be this one. Yuck. Yeah, here we go. Parse.y. So this file actually defines how Ruby should be written. You see, like it was created like really like long time ago. And if you will scroll it down, you see how complicated is Ruby. I'm still scrolling, and it's like you see like the scroller on the top right. It's like it's just here. So it basically has. Oh my God. It basically has 11,000 lines. Like it's all syntax of Ruby, and I have no idea how they support this file, because it's probably a nightmare, like go and do some like change there. Right, but it's how Ruby works, and it's basically this one is called YY. It's a YAC file. It's where you actually define all the lexemas and define how they will be transpiled later. But let me scroll to the top. But you actually can read it. Like if you go and read something like file name, you see like oh yeah, here we go. We have an operator, and like operator will be will be considered operator. This one, and like many more. And what you do if you not like kind of it's just special syntax. So like as a first step when you execute a new code, you actually get parsed from this file. And to see how this one is parsed, you should like this one is a way to execute Ruby. You can put 5, and you see like it's been 5 here. And I think if you go and say dump parse tree, oh here we go. It should be YY debug. You'll see how actually it was like written in Ruby. Like this is small, like really small line of code. Like you see, like it's 5 equal 1 plus 4, it puts 5. It gives you like this huge number of like comments and lines, and actually it's like really debug information. In real life, you will never like go and debug your Ruby, right, until you're like developing a Ruby. But I want you to understand deeply like how actually this is being organized, because after parsing all this like data with all the rules, what happens next? It actually will create a syntax tree, and it will can get it with the parse with comment. I get parse 3 with comment, parse 3 with comment. You don't know how to dump parse 3 with comment. Okay, parse 3 with, oh here we go, let's change syntax. And like actually like what happened next, it actually going to create a tree, syntax tree of your method. So you see like it will have arguments 0, body, and body will have like head and another body, and somewhere we'll have some node assigned core which is 1, and somewhere else there's a method call, like it's called, we see like we have a plus because we actually doing a plus, and like really complicated stuff, right? Like node array, literal for, which is a literal and should be converted, and then and like so on. So like, and you having this like huge syntax tree with what will be executed by like, because like why actually we need this syntax tree? Do anyone know? But it's a tree, why it's not, you know, like array or something or something else. Any ideas? Not really. So like it's really easy because it's a tree, because actually there's like several dependencies which should be executed after each word, like after each other. So we need when we have a tree, we know what's the execution order, like because like but definitely when we take in 5 or equal 1 plus 4, we need to have 4, then we need to have 1, then we need to have 1 and 4 to be like on our syntax tree, and committed plus, and then we have 5, and 5 should be go after this 5. Like, you see what I'm saying? Like it's just dependency graph. And after that, like when you was able to do a tree, you will see your code will be transported to this one. This one is actually like code which comes to your virtual machine. Like I mentioned before, like this is like how compiled languages and interpreted languages are different. Like on compiled language, you will have this tree, and then this tree will be compiled to, you know, like some, you know, really machine-specific code for your platform, like Intel and ARM, but whatever, like for some specific instruction set. And on interpreter, you will have this, you know, some intermediate language where you see like we have a put object command here, and we have special command plus here, and we have put self and so on. And this will transport to virtual machine, which in the end will go to, which will like automatically on the fly get this code and convert it to your specific infrastructure, or specific like machine and CPU. So this is how Ruby works. It has nothing to do with metaprogramming, but I just want you to know why it's actually possible, how Ruby is executing itself, and why it's so dynamic. And it's fun because like when we going back to Ruby that one important stuff you need to understand is a self comment. Can someone tell me what self means, like here? Which will be equal here. What will happen if I will execute put self? Silence. It's actually, it's not something like, it's definitely the same as this in C++. But what this will pointing out when you're doing like on a blank file? Yeah, that's true. It will be object. Actually, it's called main, but basically you like inside the global object stuff right now. Because I think if you go in RB and put self here, it will be something different. Put self here, it will be still main. Okay, it's some hack in Ruby. If you use list, if you use some older version, like 1.3, and say have it here and puts self, it's still main. Cool. Constants. Anyhow, like it's actually object, and it's true. It's a pointer to current context. And when you defining like a method here, like if you're doing like def ABC, and it's doing like some 1, 2, 3 stuff, whatever, and you executing this later on, you actually what you're doing self ABC, right? Because you all the time you defining something on object, and self is object, and like everything in Ruby is object, and it comes to really fun stuff. For example, let's say we have a class called foo, right? And you have a method called bar, which will produce your bar, which is really straightforward. And you can do foo.new.bar, and it will give you bar, right? And what will happen if I will go and say def self bar and put it bar 2? Will it be giving me bar 1 on bar 2? Bar 1. So bar 1, raise a hand. Bar 2. Okay, it actually will give you bar 1. And reason behind this is actually when you define method here with a bar, you actually like defining this on the object context. It's just Ruby, how we call it, Ruby syntax, right? But when you actually call self here, you saying that I'm on self context, like, and you will be executing this one. So you see like bar 1, bar 2. So this one will define a method on the object context, and this one on a class. And I think like did someone tell you like how to create class methods before? Yeah, so it's basically a syntax. But it's really fun because actually what can happen, which is really mind-blowing, is what you do in this stuff. You can have foo to be an object, right? And you can do foo.bar to be called. Let's remove this one for now. And what happened next? You can actually go and define foo bar and puts I'm not your bar, and call it bar again. And it actually works. And which is more really like mostly more interesting if you will go and have another foo object and call it foo bar. What will give it for you? Like will it give you like I'm not your bar, or just like bar 1? It's true, it's just one. So you see, like we get an object and we kind of replaced method inside one object, and then like we create another object and like all methods stay the same. I'd never seen this having like on Ruby, like on enterprise programming, but it's actually possible to do. And it's fun because it's actually called how a mechanism and the way it's working. It's called ghost classes. So actually, like if you're reading this right, Ruby has ghosts. And to tell you how this actually works, I need to tell you how Ruby works when executing like methods. It's also important to understand doing having some programming. I mean, doing some metaprogramming. So basically, when you execute a new method, you actually, let's say, foo, and now let's go here. Let's have bar again, and puts bar. So we have a foo, right? And foo is a class, and foo class is a class which is you will learn later. But foo have a method. No, wait, it has ancestors. Yeah, here we go. Foo has ancestors. So like basically, like foo is inherited from object and inherited by kernel, which is inherited by basic object. Like it's just like chain of inheritance. It's fine, right? So every time you actually execute a method on foo, on any object of foo, like foo new to s, for example, like it will be this one. What happens? You actually asking foo class, hey, do you have 2s method? It has like it says no. Like then it goes further. Like, do you have any like object to s method? Like no. Kernel no. Basic yes, and it's being executed on this level. So like it just goes one by one, like trying to find which one inheritance has this object, has this method. And okay, it explains how like inheritance works, but it doesn't explain what happened when I actually like created full object and actually defined ABC right here. Truth is that like in every class on Ruby, there is like special class which is called ghost class, just small tiny class, and like you can get access to this class by doing really this like super strange syntax like this one. It's also called agent class or whatever. So like in every class on Ruby, there is a small agent class. So what happens actually when you execute any method? It asking this way. It asks, "Hey foo, do you have any 2s methods in your hidden class?" No. Do you have any 2s methods in your like root classes? Yes, and so on. So like just asking twice every time. Does it make any sense for you? Because like I see some people sleeping. No. I know it's complicated. Like metaprogramming is complicated. So, but like do I explain fine? Like it's just you need to understand that every time you execute a method, it's been asking twice on a callback chain. Like hey 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 hey. All right. And to do small exercise, we are going to, I think, take this one. Give me a second. No, like we're not going to this one. One more really interesting and really mind confusing stuff is like happening when it actually like let's imagine we have a method called let's imagine we call in foo and we call in some really stupid method like this one, right? And it will give us undefined method blah blah for blah blah blah. So basically this one like it's been and again like it's called foo ghost quest. Do you have this method? No. Quest no, object ghost quest no, object quest no, and so on. And reaching like basic object, you just failing, like like it just failed because like there is no method anywhere. But it's actually not true. It's not failing when you reaching basic object. On Ruby, there is a special mechanism where you can actually define method missing. It will give you name and arguments. And what happens actually, where every time like some method reaching end of chain, it goes back and calling method missing on the object, and calling like, hey, can you all call me method missing with this name and see if anything is happening, and so on. So basically, if I will put it like put 1 to 3, actually I can even do more. Like if I put name, every time I'm calling some stupid methods on Ruby, like really like stupid ones. I have no idea how to call them. It's stuck for me. Okay, so like you see, I have really 5 stupidest methods in the world. Here we go. 4. And I will execute it. It will actually be executing fine. You see, like, just give me a string. It's a miracle, guys. Like, why are you so calm and silent? I just executed anything like in Ruby. Like, yeah, I can create anything. It just works. It's fine. So, method missing is a method which actually can generate you this method. So basically, what